Okay, this is section 7.2, and we're looking at the central limit theorem. Did you guys watch the animated one with the bunnies and the dragons? So this one is not as spectacular as that because I have no dragons flying off in the sunset. But here we are looking at page 356. The question says provide mu x bar, that's how you would say this thing, mu, the mean of x bar, and the standard deviation of x bar, and determine whether the sampling distribution of x bar is normal, approximately normal, or unknown. So these are the three choices: normal, approximately normal, or unknown. And it says, this is question 11, SAT scores are normally distributed with a mean of 516. It's probably like the math scores, maybe, or something. Anyway, not the total score, I'm guessing. Mean of 516 and a standard deviation of 116. 516 and 116. We're taking a sample of size 9. Okay, so to our picture. So again, we have X is one score. It's the population SAT score. SAT score, sorry guys, this writing is bizarre. SAT score is normally distributed with a mean of 516 and a standard deviation of 116. But we're interested in samples. So if we take a sample of 16 people and look at their average, how is that distributed? So in this case, the problem tells us that the SAT scores are normally distributed. So because the population is normal, we know that X bar is also normal. So it's normally distributed. It's not approximately normal, it is normal because it came from a normal population. So that's and we know the mean of X bar is equal to the mean of the population. That's supposed to be a little mu. So that's equal to 516. So we'll say X bar is normally distributed with a mean of 516 and a standard deviation, sigma X bar, is equal to, this is the standard deviation of the population divided by the square root of n. So this is 116 divided by the square root of, I think I wrote 16. I think it's actually 9. 9! Terrible. 9 divided by 9. So this is not an even number. This is a horrifyingly not even number. I believe it's 38 point something. 116 divided by 3. 38.66. 0.667. So you're going to get different answers depending on how you round this standard deviation. So I'm just going to say 38.67, but I'm remembering that I had to round up, so you might get slight variations. So that's part A of this. That's question number 11. It just says determine whether it's unknown. We know that it's normal. We found the mean and the standard deviation. So now we're going to look at question 17. Find the probability that X bar is greater than 540. Probability that X bar is greater than 540. Go to our picture. So here's the mean. Mu of X bar, the middle of these distributions, is 516. So let's just put 540 about here. 540. So we want the probability of everything, sorry about that line, you guys. Everything bigger than that, this side. So that's going to be the probability that X bar is greater than 540. 540. Boy, that's easy to read. Not. Kidding. So, in order to find the probability that X bar is greater than 540, I suggest doing this on your calculator. Because now we know that it's normal with a mean and a standard deviation. So if you know something is normal, you can always find the probabilities on your calculator. That is the beautiful thing about that expensive TI 83 or 84 that you purchased. So here's how you do it on your calculator. You type in second function variables, so you're going to the distribution button. Then you type in second function normal CDF. This is what we did in chapter 6. It's all exactly the same. So now you type in the lower bound, that's 540. The upper bound is infinity, but you can't type in infinity, remember? Can't type in infinity, it's from 540 on up. So you just type in 10 to the 99, comma, mean, 516, comma, standard deviation, 38.67. Again, I had to round. And then the calculator gives you 0.2674. So the book gives you a slightly different answer, and it's because of this standard deviation. So don't worry about it. This is close enough. So I suggest you use your calculator and stop the video right now. But if you didn't stop the video and you want to see how to do it on the z-table, I will also do it that way. So if you want to find this probability using the z-table, you first have to translate this probability into a z probability. You have to scale it. So what you do is you subtract the mean, which is 516. This is what we did in Chapter 6. Divide by the standard deviation, 38.67, is greater than what you do to one side, you do to the other, 540 minus the mean, which is 516, divided by the standard deviation, which is 38.67. So again, since we know that x bar is normal, this is the probability all of this turns into z is greater than 540 minus 516. I calculate that to be 0.6206. So what's the probability that z is bigger than 0.6206? You go to the z-table. So I'm looking at probabilities. 6206, I see 62, 6207, 62, oh, here it is, 6.62, 0.62. So 0.62, right there. 7324. 0.7324. But again, the z-table gives you everything on this side. So that's this. So in order to find the probability in the yellow area, you have to take, actually I'm going to go white and do it up here, 1 minus 0.7324, which is equal to approximately 0.2676, which I believe is what we got from the calculator. 2674. Here I got 2676. Close enough. So again, I really think you should use your calculator for these problems. Using the z-table is, it's just kind of another way to do it, but I don't think it really gains you any knowledge. So use your calculator, and this is how to do a central limit theorem problem. Next up, proportions.